So welcome to topic 2.8, inverse functions. This is daily video 1. In this video, we will examine the input-output pairs of a function's inverse, as well as relevant notation and the meaning of the word invertible. My name is Julie Harrison, and I work at Spelman College in Atlanta, Georgia. So let's warm up. So there are some important items we need to note regarding inverse functions. The first is notation. So given a function f of x, our inverse notation is captured by f with a -1 placed here of x. And our inverse function is a reverse mapping of the function that swaps input and output. And we read this inverse notation as f inverse of x. Let's look at terminology. So invertible is an adjective, which means able to have the position or order reversed to create a function. So we need every input mapped to one output and every output generated by one input. So let's look at an example of what is and what is not invertible. And so looking at our cubic, we have an increasing h of x. We note that it is invertible since we satisfy our criteria below. Looking at our w of x, we have in this box the increasing, decreasing, and back to increasing behavior of w of x. And we note that for this particular output chosen here, we have an output generated by more than one input. So this particular function is not invertible. So let's look at selected values for this increasing function f. Increasing, as we saw in the previous screen, would mean we have an invertible function given in the table. And let's illustrate this inverse idea using the second row. So we can write f of 3 is 9. And we can also write f inverse of 9 is 3. So let's look at an example. So an invertible function h is known to have the given information indicated in each question, and we're going to use this to highlight some additional information. So let's note that we have an invertible function, which gives us a reverse mapping of the function that obtains a new function. And we want to rewrite in question 1, we want to rewrite h of 2.6 equaling 0 to reveal a corresponding piece of information about h inverse of x. So we're going to swap our input and output to obtain our new mapping, and we get h inverse of 0 is 2.6. Looking at question 2, we want to rewrite h inverse of pi equaling -1/5 to reveal a corresponding piece of information about h. So we are going to think about reversing our mapping, and we obtain the result of h of -1/5 equaling pi. Let's look at a question 3. So an invertible function w has an x-intercept of -3, 0, and its graph includes the ordered pair 2, 7. Let's identify two pieces of information that can be correctly stated about w inverse of x. Note, we're going to reverse our mapping of the function to obtain a new function. And we have invertibility, so we're okay. So our first piece of information that we can obtain is that the ordered pair 7, 2 is on the graph of w inverse of x by reversing our mapping. The second piece of information, the coordinate pair 0, -3 is on the graph of w inverse. And in fact, this now corresponds to a y-intercept. So question 4. For a bigger than b, it's known that f of a is less than f of b. We have selected values of f given in the table. We want to use this information to answer the question below. Pause and see if you can figure out what the answer is. Okay, so we have f of a is less than f of b for all a bigger than b. And so what that means is as x increases, f of x decreases, so we have invertibility. We can use our invertible f. We say f of what is 6? We're going to read the first row of the table. So we get f of -2.4 is 6 from the first row, giving us our answer with our reverse mapping of f inverse of 6 equaling -2.4 for our answer. Let's practice. So you try this question. For a bigger than b, it's known that f of a is less than f of b. Selected values are also shown. So we want to now find the value of f inverse of 2 plus 4 f of 6. So f is invertible based on our decreasing behavior. So we say f of what is 2 and f of 6 is what? So we're going to read this two ways. So we need to read the third row for the inverse. F inverse of 2 is 3. And we need to read the fourth row for the second term. F of 6 is 1. We compile our information following what we're after. 3 plus 4 times 1 which gives us our answer of f inverse of 2 plus 4f of 6 equaling 7. Let's consider this non-invertible function p, whose graph we have here. And so there are 3 sections that can be used to create an invertible piece. So we want to choose the correct restriction that goes with each of these invertible sections. So let's go from left to right. So on the left side, we have this section, this first section from negative infinity to negative 1.423 is going to allow us to have an invertible section of p of x. We have negative 1.423 to 1.757, which is our middle section, which allows us to have an invertible section of p of x. And then we have a third section as well, from 1.757 to infinity, that allows us to have an invertible section of p of x. Let's review. So the question is, do we have invertibility or not? So take a moment and pause and see if you can identify these functions, put them in the correct group for not invertible and invertible. So let's look at group 1. In group 1, we see that we can choose an output that is generated by 2 different input values for each of these 3. We see that in group 2, we have every input generating an output and every output being generated by only 1 input. So our last question is an odd one out. Thinking on our discussion about invertible functions, which of the following below would you consider to be the odd one out? Pause and let's give a reason for your answer as well. Okay, so y equals x to the 4th is hopefully what you chose as the odd one out. And our reason is this function is symmetric to the y-axis where an output's obtained from 2 different input values. A restriction on the domain is required to make the function invertible. What should we take away? Our takeaways. An invertible function has an inverse that is a function. An inverse maps output values of f to the corresponding input values. An inverse function is denoted by f inverse, this notation here that might be new. And the domain of a function may need to be restricted in order to achieve invertibility. Thanks for joining me today.